Hi everyone, good afternoon. I'm from Intel Spark team. So our team focused on the Spark optimizations in years, about more than 14 years, I think. And today I will show the status and the plan of the Apache Gluten project. There will be several sections here. Firstly, it's a simple introduction of the gluten, and secondly, it's the current status, and then it's the performance and some characteristics of the gluten, and then it's a plan for this year and maybe next year. So firstly, what's the gluten? The gluten is a native sequence engine to offload the Spark's GVM-based sequence engine to native libraries. So itself, gluten itself is a plugin. It's a GenAI plugin here. So you can see that it's a very thin layer actually. What it does is that it transforms Spark physical plan to substrate plan and send the substrate plan to Velox pipeline and get the results. The result returned to gluten and GenAI, then the gluten GenAI returns the data pointer. It's not the data, it's the data pointer to Spark. And if Spark doesn't need to touch the data, for example, it sends to the next operator, the column to rule or the shuffle. It just pass the pointer, the data pointer to next operator. It doesn't need to use, the Spark doesn't need to decode the data. And if the Spark needs to touch the data, so it will convert the Velox format to Apache Arrow format. And then instead of the Spark, it will use Apache Arrow format to get the data into the Spark pipeline. So that's what happens. So, and the gluten offload all, since the gluten offload all the Spark sequence engine to the native library. Currently, there are two libraries we are working on. In Intel, we worked with Meta on the Velox backend, and another company called Credence, they are working on the ClickHouse backend actually. And most of the customers, gluten customers, as far as I know, they are using the Velox backend. And this is the gluten development process. Firstly, the first project is called Gazelle. It's actually not a gluten. So it's the in-house designed Apache Arrow-based sequence engine. It's not a Velox sequence engine. And at that time, we still don't know the Velox is developing by Meta. And then when we develop the Gazelle project, we offload the sequence engine to the native Apache Arrow-based the library, and we get some performance boost, but later we found that it's really hard. It's too hard for us to develop a complete native library like Velox. It's really hard, especially it's from Intel, from our very small team. And in 2021, Dave mentioned that Meta are working on the Velox libraries, and we think that it's a very good library we can use. We can use it directly. We can start our internal designed Apache Arrow-based sequence engine. And then we create a demo and 2022 and get the TPC passed and get 1.61 performance boost and runtime. In September, we got the TPC-DS passed. Most of the operators still fall back to vanilla Spark. And then in December, we got the TPC-8 got 2.34 performance boost and got the TPC-DS 1.35 performance boost. And that's 2022. And then in 2023, April, we got the Spark 3.2 and Spark 3.3 UT passed, all the UT passed. So it's the first step to get the stability of the gluten. So without the UT, many queries will fail. So after the UT is passed, then we can generally test in customer environment. And then we under the decimal support, and then the TPC is boosted to 2.21 and or 81, and the TPC-DS is 2.1. And then we release the 0. Beta release here, and some customers start to use gluten in their real customer environment, test the gluten in their real environment. And in July, we get a 1.0 release, and the TPC-8 get a 3.18, and the TPC-DS is 2.67. And then we passed the 168 functions and 20 operators in Spark. And in October, we switched to the upstream Velox. It's because that initially when we want to get the performance number as bigger as possible, and we add lots of patch to Velox, but it's not merged in upstream Velox. It's located in our internal Velox. And later, our internal Velox become more and more complex. The change, the difference between upstream Velox, it's too large. And every rebase may take, initially, each rebase take 1 week. And later, it takes several weeks. And later, it takes several months. It's really hard to rebase anymore. In that way, we decided to discard our internal Velox and move to upstream Velox. So which means that we need to upstream a couple of the features into upstream Velox. So thanks to Meta team's support, so they reviewed the many PRs and that time we just proofs every day and get the PRs merged as soon as possible. And later we started to use upstream Velox. And currently we still have our internal Velox, but it will be rebased to upstream Velox. And currently there are 15, I think, 15 PRs not merged into upstream Velox yet. So, but it's small. So some PRs are just a little modification. We are not going to merge. So that's October, last October, and also we passed the Spark 3.4, the Spark 3.4 release, and we passed the HNDS. And in December, we get the data lake support, initial data lake support, and also the spill just works. So the spill function, most of the spill functionality works. And also we added the UDF framework because for many of the customers said that the main fallback reason currently is UDF. Actually, it's not the Spark functions. So they need a framework to easily develop the UDF and support the UDF. And then it's now the March in 2024 that we contribute gluten to Apache. So when we started the gluten project with Gluten together, we make a decision that it will be contributed to Apache in 1 day. So it won't be an Intel project or Gluten's project. We need to expand our community. And in this March, we moved to Apache and move. Currently, all the source code is contributed to moved to Apache, and all the CI servers are moved to Apache. But Intel internally still have some server, have some Jenkins test. So test the performance every day and every night and get the performance number. And currently, thanks to Microsoft team's support, they passed the 3.4 UT. So currently, all 3.4 UT are passed. And the TPC is boosted to 3.23 currently, and the TPC-DS is 2.73. And we have 229 functions and 29 operators passed. So that's current status. We have a table later. So this is the current the detailed later, the operators. So we needn't to implement because the gluten itself is a GNI interface. So we can easily offload or fallback to vanilla Spark or offload to Velox library. So we needn't to implement all the functionality of Spark, like the operators, the functions, or data types. We needn't to implement that. If the customer is not currently use that, then we needn't to implement that. So that's the fallback. So currently, what we collected from our customer is that operators, Spark itself has 90 operators, and 37 are required currently, are frequently used. So, and we implemented 29 today. And the Spark functions, Spark 3.22, it's 361 functions. And what we implemented is 229, and you see, and the total number is 298. Or 89, and many customers, many companies are implementing these functions in community now. It's not only from Intel. Under the data type support, it's most of the data type definitely need to be supported. Under the data source support, there is a table, there is some detail there. And currently we support local FS, ETFS, S3, ECS, native EDFS. And the file format support, currently we only have the packet. Actually, it's the Velox only have the packet and the awk support. And some customer asked about the CSV and the JSON and the text support, not done yet. And the Spark version, currently we support Spark 2 to Spark 3.5. And the 3.5 just passed the TPC8 and the TPS. The UT is not passed yet. And also there are many customer-specific optimizations, so we are adding to. So that's the status as a server. And here is some key features. So firstly, it's Pakistan the most important. We need to get the data from Pakistan. So all complex data type currently is for banks. It's because that there is some bug still in Velox. And the timestamp is still for banks. And the 250 and 205 Spark UTs, the Pakistan UT is still for banks. And again, we needn't to implement or offload all these functions to Velox. So that's for bank is okay. But what we need to make sure is that if we offload the data to Velox, we need to make sure the Velox can pass. And the column to root column, so it's currently it's because we need for bank. So we must implement the column to root, convert the Velox column format to Spark root format, or convert from root format to column format. And currently, the two operator is offloaded to Velox. It's implemented in Velox natively. Actually, it's not use. It doesn't use Spark standard one. And the failure test passed. Till now, we didn't see issues here. And the SAFO is the most important part of the most important component in Spark. So it's the only model implemented completely in Gluten today. It's not upstreamed. It's because that the SAFO is very tightly coupled with Spark kernel. So it's very hard to get a clean SAFO service from Spark and implement them all in native. So it's either not necessary because we can reuse Spark stuff for the data transfer. We can reuse that. So, and also some optimizations in SAFO we can reuse. It's not the performance critical part. And what SAFO does is today is that we split the Velox vector into arrow buffers. So it's not it's the intermediate buffer is not a Velox format or not either not a arrow format. We just use arrow buffer. It's internal defined. And compress it and then flash to file and merge the small buffers into over root vector because each root vector has several buffers and we need to merge that and then for better compress. It's because that if the sub partitions number is too large, each split buffer is too small. So if we compress the very small buffer, the compression ratio is very high and very low actually, and the compression data set is too high. So it takes too much time. So we need to merge. And we use RPC libraries to deserialize the buffer today, and push-based shuffle is already implemented in Gluten, and it's already ended. And the remote shuffle service, the Caliban support is there, and currently the shuffle is still hash-based in Gluten. So as you know, the Spark uses salt-based shuffle. The hash-based shuffle has a big issue is the memory location. You need to allocate the memory before you shuffle and fill the data in it. But salt-based shuffle doesn't need that. But as the columnar format, and you see that the sort operator is the most expensive operator in the columnar format, because that if you serialize the data, it's a random read and a sequential write. The random read itself is very expensive. So the sort operator today is still slower than Spark. And the software-based shuffle is already implemented by community and by one company, and the performance is not good. So that's current shuffle status. And the memory management, we reuse the vanilla Spark memory management and convert it into the off-heap memory today, and it's fully supported now. The spill support, the spill is another big feature in vanilla Spark. So we currently support most of the fields and most of the field support. The exception is one is the streaming window. The streaming window it's still in work in progress. Another one is hash-based join, push the hash-based join, which means that after we build the hash table, then the out of memory exception raised, and then we need to release some memory and move the hash join to the hash table to disk. So currently, it's not yet implemented in Velox, and the Velox community is working on that. So that's the two exceptions. Okay. Generally, still it works well, and the data lake support is still working in progress, and you'll see from in the slide. And then it's a micro benchmark. So it's a micro benchmark. It's a framework to reproduce a task in benchmark in totally in native SQL, in native library. So what it does is that the below chart it's the Spark pipeline, and each pipeline has many states. Each state has many tasks. What the micro benchmark does is that it can simulate any of these tasks. So it saves the data either from the Apache file or from the shuffled. It saves the data, saves the query plan, and then input it into a benchmark and test it in single thread or multiple thread. It's very useful to debug and performance operations. So I personally use it a lot, almost every day. Use it. It's a very big feature here. We spend quite much time to add it. And the fire test. So, and when we started the Gluten project, we actually built the fire test on our machine. But at that time, we think that the Spark, once we pass all the Spark UTs, then the stability should be good enough. But later, what we noted from our customer is that it's the Spark UT just the coverage is too small actually, and there are lots of issues reported every day, and we fixed one, another one rise. So recently we put effort on the fire test here. And another issue is that what we observed or the customer observed is that it's really hard to reproduce the state in customer side. So once they see this issue from their cluster, then they need to simplify the query and reproduce on single node and then create a benchmark. And it's very frequently to happen that we spend or the customer spend 1 week or 2 weeks to reproduce it, shared us the sample data, and we just spend 1 day to fix it. So it's the bottleneck is really how to reproduce them. So we wanted to fix this issue and by a better way. So currently that's why we put most of our effort today and part of our effort today on the fire test. The fire test has two tests. One is in Velox. We will contribute to the Velox community. It's a Spark. It uses Spark Connect. It passes the circle or Spark Connect plan to Spark server and get the arrow-based data, and then compare the arrow data with the Velox or the data returned from Velox. It will be the single state. And in Gluten, there will be another fire test. It will treat the Gluten as a black box. It just test, give a circle plan and test in Gluten and test in vanilla Spark result. And then it's the current performance. The performance number, the first one is it's the SPR, and the second one is the latest Intel processor, EMR, and you can see the performance here. It's better than the one I shown before previously, because the previous test is from our Jenkins server. There we use an Ice Lake server, so we always use that to track the performance every day. And this one is used, it does test once from our latest server. And the performance number, you can see that it's there, and compared to vanilla Spark and compared to 10%. And then it's the operator time breakdown. So this is the TPC when we test the TPC, and from customer side, the customer can create a such table for every query. So from this table, from this chart, we can clearly see that which operator takes most of the time. So we can put the effort, we can analyze that operator. And the test here, it's what I wanted to, I forgot to mention is that this test is on a single node. It's not a cluster, so it's a single node. So we put enough NVMe SSDs and enough memories there. There's no IO bottleneck. So the CPU utilization is close to 100% most of the time. And with one question you may raise is that with Gluten, the pressure to network and to disk will be much higher than vanilla Spark. So the performance boost 2 times, which means the pressure to disk and to network will be. So which means that from customer side, they can add more disks and they need to add more network bandwidth to get this performance. And then this is a chart from the single node user. And you can see that the breakdown of these operators. We can ignore the details. And here is some basic characteristic of this over the Velox library when we use the Velox library. So firstly, the Velox library is a batch process. So every batch currently in Gluten is configured as 4K rows. So each batch is processed by one operator and input into another operator. So which means that the data will be fetched into a cache and then reuse it. The ideal case is that you can reuse it in. And there is some metrics here. The most important one is the memory store and the issue store. You can see it's 80%, 82%, and 73%, which means that the CPU inside of the CPU, the pipeline just stored do nothing, just wait the data. And what happens is either from a front end or from a back end. And here we can, with more analysis, it's obviously it's from back end. And the memory latency takes the most important roles here. It's because of the memory. And it's because in this chart shows the cache behavior. So since the memory latency takes the most of the role, and which means that the cache doesn't cache data. And this is the breakdown of all the memory size. So most of the time, most of the accesses can hit L1, but several can hit up to S3. It does the breakdown. And this is the low latency here. So which means that the chart shows when inside of the CPU, when you have the memory pressure, so when you have very frequent memory access, the memory throughput increase, then your memory latency will increase. And when the memory latency increase, which means that the pipeline needs to fetch the data, but the data is not there, and it needs to wait the time to get the data, and the pipeline is stalled. So the CPU is stalled. So the memory latency is the most important part in Gluten and in Velox in our test. And the pointer there shows the current position of the Velox when we run a TPC, the throughput and the latency. When it's close to 200 nanoseconds. It's actually very high. You can see the lowest one should be 100 and very high. And which means the memory latency also stalls. And then it's the roadmap for this year. There are several parts we can highlight here. The first one is that in our plan, by this September, we should have the fair test passed. We have the most of the functions implemented, 85% of the functions implemented, and we should have all the UDF or the Spark versions supported, the 3.5 support, and then we can scale the Gluten usage to more customers. Currently, we didn't promote Gluten to more Intel customers because we don't have enough bandwidth to support them. We just select some customers to land in Gluten, help them to land Gluten. And after this September, we think the Gluten can be stable enough, the coverage can be good enough to scale to more customers. And the PySpark support is another big feature. So currently, the Gluten we didn't actually, the PySpark works, but we didn't test it in CI. We didn't pass the PySpark UT. And we need to take some time to pass the PySpark, but it's very widely used here. And there is some more details here. And the next milestone is September, and then it's the end of this year. End of this year, we will do more of it. Here, after this year, something we can do is that the first one is the performance optimizations for customer workload. So until now, we optimize the TPCs very well. But from customer workload, it's far less enough. So we frequently see that some operators takes most of the time, and there is some issues like the sort operator or like the skew. So it's we need to take some time to optimize that, and definitely there will be very large room to improve. It's because that we do saw that some operators, some queries are slower than vanilla Spark. It doesn't make. Another one is the Spark AI, because our team in Intel is in the data center and the AI group. So the Spark AI, many of our other teams are working on the AI, and the Spark AI is it's generated by Deepbreak recently, and it does extract many errors from the gluten customers, and we want to put some effort. Here we have some listed features that we can follow. And in last, as Pedro mentioned this morning, the accelerator support. Definitely, there are some operators and some operations it can be boosted by the accelerators. So it's the CPU do it well, but the accelerator can do it even better. And currently in Intel, we have the QATIA, DSA, CXL. It's QATIA is for compression, DSA is for memory movement, and the CXL is for extended memory. So with CXL, it's possible that we can save the data in extended memory instead of the disk. And also we should have the GPU integration, because we did saw that some operators, not all. So generally the pipeline, the whole Spark pipeline is less it's less sensitive to the GPU acceleration than AI than AI workloads. But there are some operators definitely can be boosted. And also one more thing I want to mention is that for its accelerators, the support itself is not easy. It's not that you under it then you saw the performance boost. Like the IAA, it does improve the compression decompression time, but it increases the kernel utilization in some other operators. So it will be the end-to-end performance boost here. And in last, I want to thank the Velox team. So I worked with Pedro from Mazda and Oren for 2 years, more than 2 years. So really thank you. And without your support, it's not possible for Gluten to get this day. Okay, that's all. I'm not sure what's the time. Yeah, any questions?
Yeah. So I'm wondering what sort of work you think is needed to allow GPU acceleration to be integrated with Gluten. What changes would you have to make?
Ask a question.
Yay! Okay, maybe. So what changes to Gluten would you have to make to support GPU acceleration? What changes to Gluten would you have to make to support GPU accelerators?
The accelerators? Yeah, so that's the accelerator support today. The accelerator support. It's eventually need to be upstream to Velox. Yeah. And currently, for the QAT and IA, we add it to Gluten. So the code base is doing Gluten today. And generally, it's compression and decompression. And the QATI, it's used by the Spark Sulfur. Firstly, the Sulfur can use the compression and decompression, and also it can be used as the Apache scan, so it will decrease. And another usage is the spill. The spill. So we need to compress the data and write to disk. So the spill support is it's not yet done in Gluten.
So my question is, as opposed to JNI implementation, do you guys consider other implementation in terms of performance?
No, I think that the GNI itself is it's not really a hotspot over the Gluten what we see today.
So do you see any performance downgrade when you move to GenAI?
No. So currently, analysis from our analysis today, so the GenAI, so that's all one optimization actually from the Gazelle to Gluten. In Gazelle, we call the GenAI for every bench. For every bench, the data needed to move from Spark to every operators. But the Gluten itself, it's a state level transformer. So we transform the whole state, all the operators in one state, and then send this task, send this this data to send the current plan, the whole state current plan to native, and then the native can implement the Velox can run the whole state, all operators in the state. So the GNI calling is not frequent now.
I see. So the idea is just to reduce the JNI calls.
Yeah.
Okay, gotcha. Thank you.
Curious about the benchmark numbers there. Were TPC HDS benchmarks, did they have the fallback into
the format?
Fallback into Apache Spark, or were they all Velox compliant, the benchmark?
The benchmark is it's your Apache Spark and Boost. So it has lead on by Apache Spark and the Velox.
So
yeah.
There was no fallback with the 3x on.
Oh no. For a DS, so it's not optimizations that for some operators, not all operators can be boosted by Velox. For example, the TPC DS Q27, Q72, sorry, Q72, it has several join together and then get the data. So when we run this in Velox, all the intermediate results of each join should be materialized. So it's good performance actually. And the solution is that we need to implement the code base, the code gen feature. So we need to put the several join into one loop. But Velox today doesn't have that, so we fall back that to Vanilla Spark. I think the Q72 is the only one we need to fall back to Vanilla Spark. And another example is Q23. Some optimizations, some of our customers' optimization, they put all the field conditions together, and then the field condition can be very large. It's the condition maybe more than 50 filter conditions, and it's not efficient in Velox either. So the solution is the same. We need the code gen. Yeah. So it's another thing we actually are doing now with our customer, and we create a cost model. And then we want to evaluate, we want to learn from their patterns, which operators can be boosted by Velox, which operators cannot. And then we can get a smarter decision here. Currently, it's not there. It's we still hard-coded like the Q72. We hard-coded that. If we see 7 or 9 join together, we fall back. But we want to create a more smarter solution here. Yeah, it's a very interesting part actually.